Chapter 13. Experimental Research. Introduction. Experimental research is one of the most powerful research methodologies researchers can use. Of the many types of research, it is the best way to establish cause and effect relationships among variables. Yet experiments are not always easy to conduct. This chapter discusses the power and problems involved in conducting experiments and also presents several commonly used experimental designs. The uniqueness of experimental research. Experimental research is unique in that it is the only type of research that directly attempts to influence a particular variable, and it is the only type that, when used properly, can really test hypotheses about cause and effect relationships. Experimental designs are some of the strongest available for educational researchers to use in determining cause and effect. 2. Essential characteristics of experimental research. A. Comparison of groups. An experiment usually involves two groups of subjects, an experimental group and a control or a comparison group, although it is possible to conduct an experiment with only one group, by providing all treatments to the same subjects, or with three or more groups. The experimental group receives a treatment of some sort, while the control group receives no treatment, or the comparison group receives a different treatment. The control or the comparison group is crucially important in all experimental research, for it enables the researcher to determine whether the treatment has had an effect or whether one treatment is more effective than another. B. Manipulation of the independent variable. The second essential characteristic of all experiments is that the researcher actively manipulates the independent variables. It means that the researcher deliberately and directly determines what forms the independent variable will take and then which group will get which form. C. Randomization. An important aspect of many experiments is the random assignment of subjects to groups. Random assignment means that every individual who is participating in an experiment has an equal chance of being assigned to any of the experimental or control conditions being compared. 3. Control of extraneous variables. The researcher in an experimental study has an opportunity to exercise far more control than in most other forms of research. Some of the most common ways to control for the possibility of differential subject characteristics, in the various groups being compared, are randomization, holding certain variables constant, building the variable into the design, matching, using subjects as their own controls, and using analysis of the covariance. 4. Group designs in experimental research. A. Poor experimental designs. Designs that are weak do not have built-in controls for threats to internal validity. In a one-shot case study, a single group is exposed to a treatment or event, and its effects are assessed. In the one-group pre-test post-test design, a single group is measured or observed both before and after exposure to a treatment. In the static group comparison design, two intact groups receive different treatments. B. True experimental designs. The essential ingredient of a true experiment is random assignment of subjects to treatment groups. The randomized post-test only control group design involves two groups formed by random assignment. The randomized pre-test post-test control group design differs from the randomized post-test only control group only in the use of a pre-test. The randomized Solomon four-group design involves random assignment of subjects to four groups, with two being pre-tested and two not. C. Quasi-experimental designs. The matching-only design differs from random assignment with matching only in that random assignment is not used. In a counterbalanced design, all groups are exposed to all treatments, but in a different order. A time series design involves repeated measurements or observations over time both before and after treatment. D. Factorial designs. Factorial designs extend the number of relationships that may be examined in an experimental study. V. Control of threats to internal validity. A summary. A testing threat may be present in many of the designs, although its magnitude depends on the nature and frequency of the instrumentation involved. It can occur only when subjects respond to an instrument on more than one occasion. 6. Evaluating the likelihood of a threat to internal validity in experimental studies. To aid in assessing the likelihood of a threat to internal validity in experimental studies, researchers can use the following procedures. Ask, what specific factors either are known to affect the dependent variable or may logically be expected to affect this variable? Ask, what is the likelihood of the comparison groups differing on each of these factors? Evaluate the threats on the basis of how likely they are to have an effect and plan to control for them. If a given threat cannot be controlled, this should be acknowledged. 7. Control of experimental treatments. An essential requirement of a well-conducted experiment is that researchers have control over the treatment, that is, they control the what, who, when, and how of it. Unfortunately, researchers seldom have this degree of control in educational research. In the ideal situation, a researcher can specify precisely the ingredients of the treatment. In actual practice, many treatments or methods are too complex to describe precisely. A consideration of this issue frequently leads to consideration, and assessment, of possible trade-offs. 8. An example of experimental research. The chapter provides a published example of experimental research. 9. Analysis of the study. A. Purpose/justification. The purpose is clearly stated under objective of the study, to determine whether mathematics achievement in Edo State high schools would improve by using improvised geometric manipulations. In total, the studies represent the diversity of special interests in the field of education. In critiquing each of these studies, the authors used a series of categories and questions. B. Prior research. No research on manipulatives is cited, which is a weakness in this published study. An extensive body of empirical research supports this method and would have provided additional justification for this study. C. Definitions. Definitions of some key terms is provided but not for mathematics achievement or geometric manipulates. D. Hypotheses. The research hypothesis is clearly stated, although people think it is preferable to state it in terms of expected outcome rather than as the statistical null hypothesis. E. Sample. The sample selection seems unclear, and it appears the schools were not chosen at random, which would have been a poor method regardless, as selecting a random sample of 3 from a population of 287 is insufficient to produce representativeness. F. Instrumentation. The format and development of the mat are well described. G. Internal validity. Although the study is a true experiment in that the sample was randomly divided into experimental/treatment and control groups, hereafter E and C, the desired equating of groups is greatly reduced because it was classes, not individuals, which were randomly divided. H. Data analysis and results. Data analysis consisted of t-tests calculated separately for E and C groups. Significance tests address generalizability and require random selection from defined groups, which is not the case in this study. I. Recommendations/conclusions. Recommendations 1 and 3 are persuasive but are independent of this study.